Welcome, welcome. Hope everyone's having a good day before Thanksgiving. Everything's going well, wonderful today for y'all. We are going to attack this day five, our fifth day of AI engineering training, following along. Today, we're going to focus on creating training data. Um, our last sleepy stream, we went over exactly how we want to go about determining the difference between a wide receiver and cornerback. Give me 1 second, actually. Turn the volume down a bit. All right. Now, within this ecosystem that we're looking to create, we're going to need images of receivers and cornerbacks with bounding boxes around them in order for first, they're going to parse the pixels within the picture itself, right? We're acting as this still frame is the picture. And after creating a tensor of each pixel, it'll then slap a layer on top of it and interact with the other neighboring pixels and try to find matches, similarities, patterns, right? So first you start with red, blue, green intensity for your tensor, and then that changes to conversion convolution layer 1, 2, 3, 4, 60 to 64, 128, etc., etc. So with that understood now, let's go ahead and actually start looking to make training data. Let's actually start building out training data so that we can ingest into our AI and start seeing some results. All right. So first things first, let's go to our handy dandy AI. And it was here where we were gonna start. So step one, as always, we take a look at the answer to our question, right? First of all, our target function is y, essentially y of x is equal to receiver cornerback is what I'm assuming this is. I've seen a lot of stuff like this, so let me try to understand exactly what's going on with these types of functions, this notation, and see what we can gather from that. So we are to give the model one image that contains exactly one player tightly cropped around their body, and the model outputs one label, either wide receiver or cornerback. No boxes, no multiple players, no detection logic. Okay. So the goal is single player crop is the photo, and then it'll either determine if it's a wide receiver or cornerback. But this is interesting because it's not training how we kind of assumed it may, where it asks us, how do we want to identify, right? Ah, I see. I chose wrong. Wait. Yeah, yeah, yeah. So we're gonna start by focusing on the body posture and alignment of receivers and cornerbacks. So that's why you're looking at a single player crop with two options of receiver or cornerback using only body posture alignment. Right? This is gonna make sure that we are consistent through any, unless the grand scheme and concept of receivers and cornerbacks change. And a year from now, receivers start with a two-footed stance instead of a one-footed front, then this training should be valid for the foreseeable future. Um, if it was jersey numbers, if it was the background, that could change and alter. If it was a stadium where you're trying to determine if it's a home or away game, the stadium may change, right? But certain things like here we have an invariant, I guess you could call it, to where this must exist across all iterations of receivers and cornerbacks. first first step is we are going to create that data, construct that data set, as we said, create that training data. So how do we start? First, what are some obvious things that we would need in order to accomplish this in the first place? Well, we need single player crop, then label, receiver or cornerback, give to AI. Question mark. And I put these here because I don't actually understand yet the functionality of how this works, right? I don't really understand yet how exactly are we going to give it to the AI, but we do understand the overarching concept of what needs to be done. All right? So, first things first is we're looking for a single player crop. So, what we're going to do is something pretty simple, honestly. And to make sure I do this correctly, all right, so let's start with receivers. So, wide receivers. And stance. This is exactly what we're looking for. You see how this is consistent across all markers, right? So what I'm gonna do is I'm gonna take about 10 uh 10 clips, not clips, 10 screenshots and then edit it to have just the receiver visually. I'm thinking actually let's do one, two, three, four. Let's do 12. No, yeah, let's do 12, right? So we'll get three pictures from the left side, three pictures from the right side, three pictures from behind, and three pictures from the front, like this. Right? This will allow us to have a good amount of training data. So we can start here and go ahead and do something along the lines of this. We could say this is technically one crop that we have of what it looks like from the front to be a receiver. So we go ahead and save that into our folder for um, training, training data. Yeah. So we're just going inside of our Learn with Alexander AI engineering here, and we're gonna say training data, and we're gonna call this receiver front. Okay, front. We'll call this receiver front two, just for transparency. Receiver front one, going into receiver front two. Go ahead and save that. And then let's find one more good from the front stance. And what I'm looking for as well is I would like something a bit different than the two we've already had, right? Um, front facing, maybe. We have this, we have that. Is there no other at all? It's interesting. Stance, stance, NFL, front facing. I mean, it doesn't have to be NFL, right? It could just be anything. I know. I know there has to be. This works. We'll live with this. So Now we have receiver front three, three front facing receiver stances. Uh, right. And from here, let's figure out next how to label this. Right. Let's just start with the front facing first. Actually, no. Receiver. Wide receiver. Maybe the whole front facing was a little too extra. Uh, we just want some basic. You know what I'll do actually? Let's say, you have Calvin Johnson. Here we go. Now we can actually, okay. We might have an easier time just looking at line of scrimmage. We might just have an easier time just looking for. So we'll treat this as a right stance or a right-sided. Right, boom. Go ahead, save that. Call it receiver side one or receiver R side one. And let's see here. Right, get DeAndre Hopkins. And again, like this for me helps it make sense because I'm working in an area on data that I have a good understanding on, but replace this with anything, right? All we're trying to do is get data so that we can train our AI. What these pictures end up being for you could be completely different. This is just a nice little grounding block for lack of a better word. Um, now let's get one more. See, this right here is going to be a good left side, actually. So we'll take this as, shit, it's a GIF. We will, all right, that's unfortunate. I could mess around and try to screenshot it right when the GIF starts, but I don't see a reason. Okay, let's say Mike Evans, maybe. Alright, stance. Perfect. I want to call this the left side, but I'm not too sure about that. It's actually kind of ridiculous. There's not more side view. I mean, OBJ stance. Aha. That looks pretty. It's not full body though. Did I already do this? This is the right side. Let's double check. I did not. Perfect. So go ahead, save this. Save. Wide receiver R side three. And now we need to get lucky with some left side views. So this would work if it was full body. I don't want just the top of the body. I would really like the left side. Um, but I think the side view is going to look the same regardless. So we might just, let's try just taking it from the side and then wide receiver stance. Wide receiver back view. Which don't know if I'll be able to find that. This is pretty good. Again, we're cropping out just the receiver, right? Nothing else. We're gonna save this as receiver back one. All right. We are gonna, let's see, good front. Um, yeah, I'm not saying what I need. So we'll stop here. We'll start here for now. So right now, where are we at? I have single player crop. Now I need to figure out how to annotate those pictures, right? For what I'm deciding them to be. Okay. So first, I remember stopping here because my question was, what is a supervised setup? Supervised setup. And while that loads, let me be right back. All right. A supervised setup means the model is trained on input label pairs where the correct answer is already known and provided during training. So this is me saying this is a receiver, this is X, Y, and Z. Model predicts, compares it to label, calculates loss. Wonderful. Clearly B. So that was a good quick review, supervised setup, and let me keep track of kind of the things that I do learn. Right? Supervised setup, train data as training labels attached. Right. So how you spell attached? So supervised is because we are supervising it, whereas unsupervised I assume would be it's doing the training on its own. Um. So okay. Convert to grayscale. Randomly jitters them to crop around the torso. What? Okay. I see. So should I start with just now? I'm tempted to say it's almost silly to think that I can just do one at a time because if I'm saying all the data is a receiver, what's it making a prediction against, right? So I'm gonna have to do both, which means cool, we have this data here already. So what I'm gonna do is do this, or kind of like how it had it laid out for us. And then now let's do CPU. And same concept. Let's go ahead and find some cornerbacks. Darrell Revis. Nice. Save this. CB front one. Let's do Sherman. Alright, let's have this. Kind of similar to the last picture. This is a different angle, so go ahead and do this one like so. Save it. CB front two. We're not gonna do as many. What else we got? Devin McCourtney. Kind of random, but I don't know why he just kind of popped into my head. This is really straight on. And, you know, as I'm doing this, part of me does have a sneaking suspicion that it's not going to be enough data, so we might not even see enough results to determine the situation, right? But I don't think that we let that stop us. I don't think, let's see here. I did not, that's fine. Okay. So we have three cornerback pictures now. We have one, two, three, seven receivers. Let's do a couple more cornerbacks. I really want something from behind point of from a behind point of view. This, if this didn't have all the extra stuff, would be really nice. Same with this here. I really want the back view. If his legs were more visible, I just don't want to cheat myself. This is a good side view, in my opinion. We'll rock that up. CB side one. And then let's go ahead and find about. Oh, this is nice. This is nice. Great data. Alright, great data. CB side two. And let's get one more. If we can get a back view, we would be extremely happy. Um, this is good. This isn't. We're still gonna look for a back view, but this is definitely worth maintaining. Alright, let's see here. almost comedy. Take it way back here. Just hopefully get lucky. No, 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 no. The crazy part is I might pass one, not even notice. I like this too. I'll go ahead and snag this one as well. CB side 4. All right, so we have 7 pictures of each. So let's look into how to go about. Let's answer this question first. I already know the answer. Well, to me, I feel like I need to do both at first in order to have something to actually weigh it against. But in case I'm wrong, let's go ahead and verify. While that loads, give me 1 second. Sorry, I was thinking in my head, not speaking out loud. So reading through this, train both at once because you don't want to treat it as receiver versus anything not receiver. Right? We want specifically receiver versus cornerback because eventually we will do the skill sets of a cornerback anyway. So why not train it now, right? Same way with same with offensive line. We'll be getting these stances and then training it against defensive line stances. Right? So offensive line, defensive line. Now, to even define this in code, what I'm training looks like, image, receiver, label, receiver, label. All right. Yeah, you're right. You're right. Um, See, this 3 is interesting though because is this 3 acting as the color? It should be only 0, 1, 2. So what's that 3 doing? We'll get back to it. Okay. So suppose so how do I label? All right. So now how do I label? So we're looking to actually go ahead and label those while that is actually happening. Since I am on WSL here, with my Visual Studio Code, one thing I am gonna do is move all that training data, copy it over to my WSO. This will allow me to use those pictures and etc. Right? So I copied that over. So now inside of here, you have my training data, which we're gonna move to just data. Right? Here we can do training data. Right? And if I go into here, then you have CB with all the PNGs. And what I want to know now, obviously, and one thing I do want to do, let me actually try to give some more space there. Okay. So one thing that I do want to do is, like we said, figure out how to annotate. So every crop, yep, every crop that is a cornerback goes, yep, perfect. Do the label mapping for you. Okay, so what is happening here, right? Let's not skip over this. Let's take it one module, one library, one parameter, one whatever at a time, and truly understand what's going on. So, what is Torch? Vision dot datasets dot image folder. So not train. It crawls a directory like structure, class A, class B. Each subnode folder name becomes a class name. Each file inside becomes a symbol of that class. Okay, so because it's already named class A, 01. Got you. Okay. And the image tensor, the three, from my understanding, so the three, what, three stands for which PNG inside of the. Yeah. Sorry. Sorry. We definitely did go over this too. Understanding that it's RGB, but I got confused with this because there is a point in where it goes for each color to calculate the final intensity of each pixel. But let's okay, cool. So each subfolder becomes a class name. It returns image tinsel, right? It returns. So when you're doing this and you're passing the data, so I'm doing datasets image folder of training data, right? Which will then automatically parse through CBN my receiver, CBNWR, in order to provide us with all the labels for the training data. So that's going to be good. Source the subfolders automatic alphabetically assigns class. Every image returned is image tensor, which is going to be the RGB. So it's going to be 3 pixels and then the label, whether it's 0 or 1. Uh, the label is just an integer. If you start from full game frames, you first use an annotation tool, export the boxes, then you drop them to the folder. Makes sense. Okay, so now, how do we start coding? And I know from what I've received, the input feedback I've heard sometimes is a question like this, and when regarding to AI, isn't necessarily the best, right? Just how do we start coding? Very vague, very open-ended, very like, just do it for me, right? But sometimes you just don't know where to start, and that's okay. The same way I wouldn't know how to start with just programming in general, right? Ask. And then after that ask, you get your information. From there, you don't just say, okay, cool, awesome. So I just do this. I touch file. I come here, and I just do this, and it's like awesome. I just programmed, man. I did it, right? No, no. That's what we're gonna do, right? We're gonna delete that because what's important is what we know why we're doing all the things that we're doing. So we're gonna look here and we say import torch. Well, we already know what torch is doing. It's gonna handle the image parsing. It's gonna handle the tensors. It's gonna handle uh, the entire backend to working with our training models, right? So then from Torch utils data, which is some modules within this overarching library, we're going to import data loader. So what is data loader doing? What's that for us? Um, so what I would normally ask is break down, right? This just makes it easy because I don't have to ask each time which is which. It'll go through and we just keep walking through and breaking down everything. But I'm gonna ask directly, what is data loader? I assume it's loading the data, but what exactly is it doing? Instead of you pulling one sample at a time, data loader samples batch, samples to where image batch dot shape is the batch size. So this is gonna be, I assume, how many. Okay, so there's 7 images. So it's seven images, RGB height and width, and then the batch labels is gonna be seven. Lets you iterate through sample by sample, batch by batch, without writing index logic for image. Okay, so it's just creating a data set for me to loop through for ease of use. Okay. Data set gives you a training sample each time you index it, gives you a batch of samples each time you index it. I see. So I could have multiple batches of samples passing through data layer, which would be way more efficient than having all those same batches split into single training samples and using dataset instead. Um, what object does the training loop iterate over? It's going to be iterate over the data loader because that contains the batches, right? Whereas the data set, uh, which object does the training loop iterate over? Let's go data loader. Okay. Add a pre-trained backbone and replace the classifier head. Um, no. And I say no because next we're gonna look at this. So, what is torch vision? I understand it's for visual, right? Where you have torch audio as well for audio. But let's really get in depth. What is torch vision and data set, transforms, and models? All right, so we're gonna take the time, go look at torch vision, go over the data sets, transforms, and models. It's torch vision, a library that sits on top of PyTorch, which is everything that we're using essentially for this. Computer vision utilities, if not do it by itself. Provides dataset loaders for images. So this is saying, okay, torch vision dot datasets is different than a dataset loaders. Data loader. So, so what's a dataset loader? Dataset versus a data loader, right? Versus a data set loader. And now, because I have been using AI for a while, I kind of understand sometimes when it confuses itself. And this is a case where I'm getting that suspicion, right? That it's messing up its own terminology. So I'm gonna go here into the real world, I guess you could say, and try to understand maybe some more, right? So give me 1 second, I'll be right back. I have returned. All right. So, as we were looking before, the difference between dataset, data loader, and dataset loader, the dataset itself stores the data sample and their corresponding labels. So, the dataset is storing the picture and what it is. So, in other words, to me, a dataset is pic, comma, can like curly braces this. All right, this is a DS dataset. Okay. And then we have our data loader, which is wrapping an iterable ar- around the dataset, around the picture and label to efficiently fit and organize data into many batches. So maybe I'm not understanding what a data loader is exactly doing to a dataset. How does a data loader wrap around a data? So it stores a reference to the dataset. So, okay. And then it calls it repeatedly when you iterate. But if I'm iterating over, knows how to return one sample. Dataset of I, so zero. Dataset zero. Okay, so dataset is like an array which contains, I guess, more like a dictionary maybe, that contains. Oh, okay, so dataset. Okay, so you have a dataset, and this is dataset. You're zero is the dataset, one dataset, whatever. A dataset, the set is you have the picture, and then you have the label. Okay. From there, the data loader will take X amount of data sets and then create it as a batch, which then iterates through all these data sets of imitators to test. Test data set 1, 2, 3, 4, which is just the picture and the label. So data loader just allows for that to happen more with ease. And data set loader, the phrase refers to data set, the later object itself. Okay, so the data set loader is the actual data loader. Gotcha, 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 gotcha. So, with that being said, what is Torch Vision dataset? So now we know what a dataset is, right? Uh, so dataset provides dataset loader for images. So dataset is allowing. Oh, so datasets creates the dataset. It's not providing a dataset loader. It's creating the dataset in the first place, which will parse. It'll grab the file, and then it'll also label the file based off of its parent directory's name. So that receiver directory, all the pictures of receivers inside of it will be labeled receiver simply because the parent directory structure is set up that way. Transform is to modify the image before they go into the model. Resize, crop, normalize, convert to tensor, grayscale, apply jitter, blur, all this stuff that is said I should be doing is what we're going to do here in the transform. That being said, I believe the only thing that will be important necessarily is transforms to tensor, right? The resize might be nice to have some normalization between everything. The center crop might be nice, but I don't think it's necessary and as necessary as to tensor. Right? Then we say, okay, we're creating an object of train dataset equals datasets dot image folder, which is going to be my uh, training training data folder, right? And then transform TFM. I guess we're applying this transform action onto every single file that's inside of that folder. And then you're creating a loader object from the data loader class that we imported using the files found from train DS, which are creating data sets. and then creating a batch of 8 at a time, shuffling through them. That do you Okay, this is the first time I've ever openly kind of talked about my thought process and how I go about learning things. But this is exactly what I mean by taking it one step at a time. The, the understanding of the whole becomes clear just by itself, right? Not even 5 minutes ago, I look at this and we've seen this before. We've seen this before. We've seen all of this before and had no idea what it meant, right? And we could try to death by fire hose. We could try to sit here and make this work by copy pasting, and it's not working. Well, this isn't. Oh, this path is wrong, and so I do training data slash receiver, and then that has issues because X, Y, and Z. The batch size. What's the batch size doing? I don't really know. I keep it at 8, but I only have 7, so there might be an issue with that. But now that we took the time. We understand Torch. We understand what a data loader does. We understand data sets. We understand transforms. Next, we need to understand models, but we can get all the way here to now fully be able to break down all of this code without just copy pasting. And it took 10 minutes. It took a couple minutes rather than just using stuff for no reason. Not no reason, but without understanding what's behind it, right? So, boom, boom, boom. Wonderful. Next, load pre-trained ResNet 18. First of all, actually, let's go ahead and take some notes. I need to be a bit better about that. So data sets, in essence, are key value pairs in a way, right? Not really, but kinda. Of tensor plus label. Well, image plus label, right? The image is the key, the label is the value, right? Transforms normalization to images for proper parsing. And then what was the models? So let's go over models now. Data loader. Forgot about that. So your data loader and just data sets by groups for training. Transform the apply normalization to image proper parsing. And now, first of all, I understand this is a model. I've seen this a couple times. What is this, by the way? Explore more. Hold on. Let's, I'm kind of curious. I've been seeing this and explore more. Aria. I guess this is the built-in for Opera. Okay. Oh. Oh. This is. Oh. Oh man. I could do this anywhere. Oh. Okay. How many for this month? Oh. Wow. Wow. Okay. I did not know this was a thing. Wow. It's literally what I'm doing by saying, okay, what's res at 18? Well, let me come over here, right? Same function. And I don't need a super high powered AI for simple definitions. It's just, but to now be able to do it inside the browser, inside of where I am and not leave, it's actually really amazing. Um, this is great. So let's see here. models. So provides pre-built neural network architectures, and we bring neural network. Well, no, we actually let's get a good definition of a neural network exactly, because we understand deep learning, we understand. Let's see, we went over mimicking human learning, which was deep learning. This is machine learning, and then this was natural NLP, natural linguistics programming, I believe. So this concept of a neural network we haven't actually touched on yet. So it's a computational model, which again is going to simulate and study complex systems by applying algorithms. Okay. And this might seem silly, right? You can kind of infer what a computational model is, but is am I crazy for not knowing the definition of that directly? Like I'm a computational model, right? Whether that is or is not something that should be known. End of the day, all it takes is 2 seconds. Okay, now I know. Move on. Um, crack open neural network again. I don't know if it's taking long. Okay. Computational model inspired by the structure and function of human brain. So it's basically deep learning, right? Deep learning, machine learning. It's the deep learning. Okay. So it's just a part of deep learning with optional pre-trained weights. They're just functions returning a PyTorch model. Okay. So what's a pre-trained weight? You understand? Because that's the key to this, right? That's the whole key of models is they have their pre-built neural network architectures with whoa, no. That's not the key. A pre-built neural network architecture. Why am I not building my own? Why maybe I do. You don't know what I do or don't have background in. Maybe I do have millions of label receiver and cornerback examples. I do have a GPU. Maybe I did. Maybe I will in the future. I no maybe. I 100% will. But okay. So I'm not here yet. This though, in the future, I can already tell you is going to be a video series. We're going to build our own neural network architecture from scratch and that will be what we'll do after all of this. After we complete just a basic model for what we're looking to do. So honestly, I think this is a good stopping point. I think this is a really good stopping point. Models. Because what happens now, what happens next at least, uh, pre-built neural architect, arch, architecture with optional, what was it, weighted sum. And by sum, I mean like something, something, some, not some, like some, like, I guess. Uh, yeah, to me, what's next, now that we understand the models, transformers, we understand everything that's being imported into the code, what comes next is actually writing out the code, getting it to work what we need, and starting out with passes, getting some logics, right? The raw the raw prediction values. Uh, we'll go over layers. We'll figure out everything that's happening here before we even actually write it. And then tomorrow, well, Thanksgiving tomorrow. Eh, we still might find time. Tomorrow we will finally get some hands-on code. All right. So we're 5 days in of just straight theory crafting, straight, knowledge building, understanding about the background, the baselines, the infrastructure of how it all works. And now we are able to then move forward with everything that we've learned and be able to actually apply the knowledge, right? So 5 days, it's a week, yeah, uh, but realistically, we're talking an hour. That's, I mean, we spend an hour scrolling on our phone. Finding an hour a day. This is the key to what I'm trying to do as well. Is make sure every video is an hour for the majority of us, right? There are people out there with extremely busy lives, extremely hectic environments. I understand an hour can be the difference between life or death, right? But for the majority of people, an hour can be found. 30 minutes here, 30 minutes there. It's possible and it's doable. So my goal with every single series is to take it a video at a time, 1 hour at a time. So if it takes me 6 months to be able to do this because I'm only taking an hour, that's something I'm gonna have to live with because I want it to be true to everyone who views this content, who try to get understanding of anything, right? When I do a lesson or a series on learning the piano, whenever I turn around to really start focusing on learning the piano, it's as if you only have an hour a day to work. So you spend that hour a day doing X, Y, and Z, getting to where we need to get to, and keep moving from there. But time and time again, we're gonna keep pushing forward, and we gonna see. I know for myself already, I'm ecstatic, and it's been exciting so far. Looking back at just 3 days ago, not even knowing what any of this meant, right? Every single day we get that satisfaction. So that is it for today, though. Stay tuned for more. We are going to we are gonna do this, man. We're gonna do this. So hope y'all enjoyed. Hope y'all learned something, and see y'all next time.